The City of Rocks looks like something from another world with ancient granite, dramatic cliffs, and breathtaking views.
Standing over 60 stories tall and holding 2.5 billion-year-old granite.
Beneath the dense forests and ancient granite of Quebec's rugged landscape, geologists have uncovered a stunning secret hidden for millennia. A newly identified meteor crater, massive in scale and preserved under layers of rock and time, has triggered a red alert across the geological community. This discovery didn't come casually or without drama. It was born out of a series of seismic anomalies, strange magnetic readings, and subtle deformations in the Earth's crust that, at first glance, appeared to be natural quirks of geology. But as the data deepened and analysis advanced, something astonishing became clear. The scars of a cosmic impact had been hiding in plain sight. Before we start, smash the like and subscribe buttons for more updates. The crater, now confirmed through deep penetrating radar and core sampling, is one of the most significant meteorite impact structures ever identified in North America. Measuring several kilometers in diameter, the basin reveals the unmistakable characteristics of a high-energy extraterrestrial collision: shocked quartz, breccia formations, and a symmetrical structure consistent with known impact sites around the globe. Yet what sets this discovery apart is not just its size, but its state of preservation and the mystery of its concealment. Buried beneath layers of sediment and metamorphic rock, the crater was shielded from erosion and surface activity for untold ages. Unlike more prominent sites such as Arizona's Barringer crater, which is visible at ground level, this one was essentially camouflaged by the relentless churn of geological time. The forests above it grew and died for generations without ever betraying the cataclysmic event that once shook the planet below them. The discovery has upended prior assumptions about the region's geological history and is forcing scientists to reconsider how many more hidden impact sites might lie undetected beneath Earth's surface. This particular crater was initially hinted at through unusual gravitational anomalies picked up during aerial surveys for mineral exploration. Gravity maps showed a slight but consistent depression, a gravity low, often indicative of subsurface cavities or dense impact melt rock. When this anomaly coincided with magnetic disturbances and shock wave patterns in the surrounding strata, the interest of geophysicists skyrocketed. Advanced LiDAR imaging from drone and satellite sweeps confirmed a near-perfect circular depression, invisible to the naked eye but undeniable in the data. What had once been dismissed as a collapsed volcanic caldera or a glacial remnant suddenly took on an entirely different character. Geologists quickly mobilized, forming an interdisciplinary team to drill exploratory cores. What they found stunned even the most seasoned experts. Beneath the layers of quartzite and shale was a zone of violently deformed rock, fused into glass and peppered with microscopic diamonds. Unmistakable signs of an impact event. Isotopic analysis of the rock samples traced their formation back to a singular moment of intense pressure and heat, consistent with a meteorite impact from deep space. The energy released during the event would have been thousands of times more powerful than any man-made explosion, enough to vaporize rock, reshape landscapes, and even affect the climate if large enough. The implications of such a discovery are profound. This crater is more than a geological curiosity. It's a portal into Earth's violent past, a record of a celestial collision that likely had far-reaching consequences for the biosphere. Depending on the age of the crater, which scientists are still working to determine with precision, it could be tied to extinction-level events or significant climate shifts. Radiometric dating of melt rocks and surrounding sediments will provide crucial insight into whether this impact coincided with known mass die-offs or major shifts in Earth's evolution. If so, this hidden crater might help solve long-standing mysteries about the timeline of planetary change. Quebec's terrain, marked by ancient shields and glacial scars, is notoriously complex. Yet this discovery proves that even in such well-mapped territory, the planet still holds secrets of cosmic origin. The red alert issued by geologists isn't one of impending doom, but a call to urgent exploration. The discovery of the crater sets off a cascade of new questions. What type of meteorite caused the impact? Was it metallic, stony, or a rare chondrite? How fast was it traveling? What was its angle of entry? The answers to these questions will not only illuminate the nature of the impactor, but also refine our understanding of impact physics and the probability of future strikes. Equally important is the potential for this site to become a geological benchmark. By studying the crater's internal structure, mineral compositions, and deformation patterns, scientists can improve their models of impact dynamics. These models have applications far beyond academic circles. They inform planetary defense strategies, guide NASA's simulations of asteroid impacts, and shape international efforts to mitigate the threat of near-Earth objects. A well-preserved crater like this offers a real-world laboratory to test and calibrate these vital simulations. The crater's remote location may have contributed to its concealment, but now it plays a different role, protecting the site from immediate human disturbance. Researchers are working to secure access and establish long-term observational platforms around the impact structure. These platforms will host everything from seismic monitors and magnetometers to drone-launched spectrometers, designed to capture a continuous stream of high-resolution data. Every reading, every mineral fragment recovered, every layer peeled back reveals more about a moment in time when a rock from space collided with Earth and changed everything in an instant. As the crater is further explored, scientists are particularly interested in the environmental context surrounding the impact layer. Traces of carbon, microfossils, and pollen in nearby sediment cores can provide a snapshot of the planet's biosphere immediately before and after the event. If the impact had global consequences, dust clouds, acid rain, or shock waves through the atmosphere, these subtle clues will remain embedded in the geological record. Already, preliminary sampling suggests there may be an unusual boundary layer rich in iridium and soot, reminiscent of the one found at the KT boundary that marked the end of the dinosaurs. If validated, this could elevate the importance of the Quebec crater to a whole new level. There's also the economic dimension of the discovery. Meteorite impacts often bring deeply buried materials to the surface or create conditions for unique mineral formation. The intense heat and pressure can produce valuable ore deposits, nickel, copper, platinum group elements, that become concentrated along the crater's periphery. Mining companies are already paying attention, eager to understand whether this hidden structure holds more than just scientific treasure. While the focus remains on research, the tension between preservation and exploitation is likely to grow as the crater's true extent and contents become clearer. This balance between science and resource extraction is delicate, and already voices are emerging calling for the area to be designated as a protected geological site. The argument is straightforward. This crater is a finite, irreplaceable window into Earth's, and by extension the solar system's, violent infancy. Once disturbed, its context is lost forever. A coordinated international effort may be needed to secure the site, not only from commercial development but from the degradation that comes with unmanaged access. Beyond science and economics, there's a deeper human fascination with craters. They are reminders of the universe's unpredictability, the sudden chaos that can descend upon a world at peace. They speak to forces beyond our control, to stories etched into the bedrock of our planet by celestial hands. Standing on the edge of such a site, even if hidden under forest and soil, evokes a primal awe. This particular crater, sleeping beneath Quebec's trees for eons, now reawakens our collective awareness of Earth's place in the cosmos. As word spreads of the discovery, the global scientific community is aligning resources and expertise to study the site in unprecedented detail. International teams are being formed, research grants allocated, and satellite time booked. The crater will soon be mapped in 3 dimensions, its subsurface features reconstructed virtually, its materials cataloged down to the atomic scale. Every aspect of this hidden scar from space will be analyzed, debated, and revisited, yielding insights not just about this single impact, but about all those that have shaped the Earth since its formation. Even the process of discovery is reshaping how future impacts might be found. The technologies used, gravitational mapping, LiDAR, core drilling, and isotopic dating, are becoming more refined, more automated, and more scalable. With this find, geologists now suspect there may be dozens or even hundreds of similarly hidden craters scattered across the continents, buried under deserts, jungles, and oceans. Each one holds clues to ancient collisions, some of which may have forever altered the course of life on Earth. Quebec's meteor crater has cracked open the door to a broader search, a geological treasure hunt now energized by fresh momentum. What happens next will unfold over months and years of careful study. For now, what matters most is what has been revealed. A celestial bullet hole in the crust of Quebec, hidden until now, but destined to become one of the most important geological sites in the world. In a single moment of discovery, our understanding of Earth's history has shifted. The implications are vast, the mysteries many, and the journey of unraveling them only just beginning. The revelation of the hidden meteor crater in Quebec opens an entirely new frontier in both geology and planetary science, not just because of what it tells us about Earth's past, but also because of the technologies, methods, and theoretical frameworks it now challenges. Every detail that emerges from the crater's structure, mineralogy, and stratigraphic context will serve as raw data to test and refine the prevailing impact models that scientists have relied on for decades. And yet, the real intrigue lies in the questions that are only now beginning to take shape. Questions that extend beyond the immediate geological context into fields as diverse as planetary defense, climate modeling, and astrobiology. One of the most striking elements of this discovery is its potential to rewrite the local and regional geological narratives of eastern Canada. Quebec's landscape, part of the Canadian Shield, is considered among the oldest and most stable portions of Earth's crust. For centuries, geologists have studied its ancient rocks to understand early Earth processes, assuming that most significant tectonic or cosmic upheavals had already been identified and accounted for. But this crater, buried under layers of seemingly undisturbed terrain, proves otherwise. It suggests that even in regions deemed geologically quiet, the past may be far more dramatic than previously imagined. This raises an uncomfortable truth. Our maps, models, and assumptions might be missing entire chapters of Earth's story. This also highlights a long-standing bias in crater detection. Impact sites tend to be discovered where erosion or lack of vegetation makes surface features easy to observe. Deserts, tundras, or regions subjected to aerial surveillance for unrelated reasons like mineral exploration. Forested, mountainous, or sediment-heavy areas, like those found throughout much of Quebec, can easily conceal impact structures for eons. The implication is staggering. If such a massive crater can remain undetected for so long in a relatively well-studied area, how many more are there? What if the record of impacts we currently rely on to understand Earth's collision history is grossly incomplete? This incompleteness has ripple effects across many disciplines. For instance, impact frequency models, which help determine how often Earth is hit by meteorites of various sizes, are partly built on the known record of terrestrial craters. These models influence everything from risk assessments to space policy. An undercounted crater record would imply that Earth may be more frequently impacted than previously thought. Even if most of these impacts are not extinction-level events, the energy released in each case, equivalent to multiple nuclear detonations, can have regional, if not global, consequences. Atmospheric chemistry, ocean temperatures, and even ecosystems can be altered, especially if the impact occurs in a sensitive climatic or biological period. What makes this Quebec crater particularly significant is the pristine nature of its geological preservation. Because it's been protected from erosion and weathering, the crater retains many of its original impact features that are usually lost or heavily modified over time. This preservation gives scientists a rare opportunity to examine the early post-impact processes with a level of clarity that is often impossible at older or more exposed sites. Shock metamorphism effects, hydrothermal alteration, and even the settling of ejecta can be studied in fine detail. This allows researchers to model not just the moment of impact, but the centuries or millennia of transformation that followed, providing insights into how planetary surfaces evolve after such catastrophic events. Moreover, such a well-preserved crater could reveal biological implications rarely accessible in more degraded sites. The idea that life may not only survive, but possibly be nurtured by the chemical and thermal conditions following a meteorite impact is not new. There is growing evidence that hydrothermal systems created by impacts could provide the right conditions for microbial life to thrive. On early Earth, such environments may have served as incubators for primitive life forms. If remnants of such systems can be found within or around the Quebec crater, they would offer a real-world analog for studying life's resilience and adaptability in extreme environments, a concept central to astrobiology and the search for life beyond Earth. The mineralogical composition of the impact melt and breccia layers could also tell us something new about the composition of the impacting body itself. Each meteorite carries with it a unique chemical fingerprint. Its isotopic ratios and elemental makeup can point to its origin within the solar system, be it an asteroid belt, a fragment from a larger planetary body, or even, in rare cases, interstellar space. If the Quebec impactor turns out to be chemically unusual, it could indicate a source not yet represented in our meteorite collections. Such a finding would raise profound questions about the diversity of objects that intersect Earth's orbit and the dynamics of the solar system's history. The crater's discovery also poses fresh challenges for remote sensing and Earth observation technologies. The fact that such a prominent feature escaped detection for so long is not just a testament to nature's ability to obscure its violent past, it's a call for improved detection tools. Geophysicists and planetary scientists may now revisit satellite data and gravitational maps from around the globe, using algorithms fine-tuned to the patterns observed in Quebec. Machine learning and AI tools trained on the crater's unique signature could be used to scan massive datasets for similar hidden anomalies. In doing so, this crater may help create an entirely new methodology for uncovering the planet's buried scars. Another arena that this discovery intersects with is the ongoing discussion around planetary defense. While the Quebec impact happened in the distant past, the possibility of future strikes remains very real. Understanding the scale and nature of past impacts helps humanity prepare for potential future threats. Data from this site could be fed into kinetic impact simulations or atmospheric entry models that guide current asteroid deflection efforts. In this way, a long-forgotten catastrophe becomes a tool for future survival. From a geological standpoint, the crater also offers clues into how Earth absorbs and distributes the energy of a large impact. The pattern of fracturing, the zones of melt and recrystallization, and the way pre-existing geological structures responded to the shockwave all contribute to our knowledge of crustal behavior under extreme stress. This is not just academic curiosity. It has applications in earthquake modeling, resource exploration, and even nuclear test monitoring. The more we understand about how the Earth reacts to high-energy events, the better we can model its behavior in other high-stress scenarios. Then there's the cultural and historical context. Indigenous communities have long inhabited regions throughout Quebec, and some oral histories passed down through generations contain references to skyfire or earth-shaking thunder that some anthropologists have speculated could refer to celestial events. It's too early to make definitive connections, but this crater offers a potential bridge between science and indigenous knowledge systems. Collaborative research that respects and includes traditional knowledge might not only enrich the scientific narrative, but also offer a deeper, more holistic view of how ancient peoples perceived and interpreted cosmic phenomena. The local topography, altered subtly but meaningfully by the impact, may also influence modern hydrology. Impact craters often become basins for lakes, aquifers, or even mineral-rich wetlands. If this hidden crater intersects with current water tables or subsurface flow systems, it might explain certain anomalies in regional water chemistry or flow behavior. These effects, though less dramatic than the impact itself, ripple through ecosystems and could influence conservation efforts, land use planning, and even agriculture. Environmental scientists will also be eager to determine how the crater and its immediate surroundings evolved ecologically over time. The regrowth of flora over an impact zone tells a story of recovery, how ecosystems rebound from massive disturbance. In this, the crater is a natural laboratory for studying ecological succession, resilience, and the long-term effects of thermal and chemical disruption of soil layers. This research could provide useful analogs for understanding how ecosystems might adapt to other large-scale disruptions, such as volcanic eruptions, nuclear accidents, or even the long-term consequences of climate change. Educational institutions, too, are beginning to take note. There is already talk of turning the site into a living classroom, a place where students and researchers can study not just geology, but planetary science, biology, physics, and even philosophy. The philosophy of catastrophe, chance, and continuity. The crater is not just a hole in the ground, it is a gateway to understanding existential risk and planetary heritage. Fieldwork in such a location could inspire the next generation of Earth scientists, thinkers, and explorers. In the long arc of planetary evolution, impact craters are punctuation marks. moments where the course of development was sharply altered, sometimes catastrophically. The newly discovered structure in Quebec is one such mark, a hidden ellipsis in the sentence of Earth's history. With each core sample, each scan, each new insight, we get closer to decoding its meaning. And with that, our picture of the planet's past grows richer, more complex, and ever more connected to the cosmos that surrounds it. The silence of this crater, the centuries it spent buried and unrecognized, lends it a kind of gravity that goes beyond its mass or energy. It reminds us that the Earth is dynamic not just in motion, but in memory. Its crust holds stories it doesn't readily share, but now, one of those stories has risen from the rock. It begins with a flash of light in the sky, ends in a forest in Quebec, and continues wherever curious minds dig into the ancient silence beneath our feet. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the hidden crater? Will it reveal major past impacts? We want to hear from you. Thank you for watching, and see you next time.